Hello, this is Steph. Welcome back to my channel. After a long time, you see my hair that is getting longer. But anyway, I will try to cut them as soon as possible. We're talking about 360 videos. So this is a topic that honestly is something that I don't know so much about. But during the quest, during the journey, I learned a lot. So I would like to share some information with you and how to create videos in 360, even if you don't have the fancy device about 360 cameras or many devices that many cameras, contemporary cameras, to create your 360 videos of choice. So now they're not so widespread. Honestly, I don't see so many videos like this, but it's something really interesting, and so especially now with the metaverse or something like this, maybe this is something that will be more and more common. Who knows? Only the time will tell us what will be the truth. For the moment, let's see how what are the problems, and how can we implement the things, how to create our videos of our own and ready to be uploaded on YouTube. So let's have a look. Here we have Windows, but the same thing can be done on Linux, I guess. So let's get started. Honestly, in the beginning, I didn't know where to look around because I'm not so much into the 360 video. So I tried to inform myself, and I found out, first of all, the video by Vittorio Giovara. Vittorio Giovara is the director of video encoding and streaming at Vimeo, so not the first person who talks about video that comes around, that made a speech at the MOOCs of 2022. So talking about the VRs, so video encoding and virtual reality, spatial 3D and ambisonics. So here we don't deal so much about the audio. A thing that is available in FFmpeg 6 is the availability for the ambisonics video. So audio coming from multiple sources. So nothing like mono, stereo, so something a bit more elaborated. So this is this has the support, something that I didn't mention in the previous video of mine about FFmpeg 6. I will put the link in the cards right here, and I will put the link in the description about this video. So he describes very well in the beginning that the various types of 3D videos that you can create. So basically a video or an image is a 2D thing, but we want to take something in 360 so it involves another dimension. So how can we involve the third dimension? We're going to look at it straight away. So as Vittorio also describes very well, either you have the right hardware to create 360 video, like something like this. I'm taking the Wikipedia page that talks about this problem. So either you have a device that has a lens on one side, a lens on the other, both are wide angle lenses, so possibly something that covers 180 degrees, so 180 degree, 180 degree, then you stitch the two videos together and you create a 360. So either you have something like this, or you need to work by projection. So another page that is available right here is the 360 video projection. So the most common are the Equirectangular and the cube map. So this is the one that is used more often because they are very easy to work with. So here we have an example where the Equirectangular has the thing that creates an image as creates the longitude and latitude of a sphere linearly to a rectangular image. This is the definition as it is in Wikipedia. It's more or less what is happening in the maps. In fact, if you take a normal map on a planisphere, usually you have the extremes, the top and the bottom, that are extremely distorted. And so there might be a distortion, especially on the top and the bottom. So this is something that creates maybe some problems. What you have on the horizon, so in the front, corresponding to the equator of a map, this is something that appears more or less with no distortion, but everything that is on the sides appears a bit distorted. What regards the cube map, the cube mapping is something like displaying on the faces of a cube. So you have 6 surfaces that you can project your things to. Thing is that considering the singular faces of the cube, you have everything distorted. But once you stitch everything together and you look around, everything seems a bit more natural. As you can see, you have a figure per face, then the top and the bottom, and so you have everything stitched together in a cube map space. The other type of projection is the equiangular cube map. This is the one that is used by YouTube. So YouTube uses this system. So once you have a 360 video, this is the one that is used. And we can create videos like these. And the last one is the one used by Facebook that has a pyramid geometry. So you have something that is mapped into a pyramid. So instead of having a cube in front of you, you have the vertex of a pyramid that is going in front of you. So these are more or less the most common projections that you might have. Let's see which is the most comfortable to use as soon as you start with projects like this. So this is the page from the Facebook engineering, so Meta, engineering at Meta website. And this is the depiction of the pyramid that they would like to intend. So they said that they have an 80% reduction in the amount of data respect to the cube view, and it still maintains the same performance of the cube projection. So instead of projecting a sphere in a cube, they project the sphere in a pyramid. So this may guarantee a better view. The same view, but having less faces, you have less data. So that might be one of the principles which might work. Okay, here we go. So now the first video we would like to analyze is a video coming from Vimeo. Before we were talking about Vittorio, and so Vimeo, here we go, just like a tribute. And here we have the download button for this video. This is a video set in Thailand, as you can see. And this is a 360 video that is equirectangular as a 360 projection. So what we would like to do is to analyze the video first of all. This is a video that as soon as you play it, it doesn't have any 360 projection, so you cannot go around. Now let's see how to go around. FF play. The video is called Ayutthaya, and all with this big name. Here you have this with the typical equirectangular projection, and FF play cannot play the 360 videos, neither MPV. So to try with MPV, it plays but 360 depiction like this. VLC can play the video. So here we have the folder where the video comes from, and here, if we play the video, this is not 360 because I think that we need to do is to include the metadata that this is a 360 video. So let's have a look at this first. So to add the metadata regarding the 360 video, we can't make it with FFmpeg, they already know. But there is Google that releases something like the 3D metadata injector. So we have something like this, spatial media metadata injector. This is something coming from 2018, And if you have the 64-bit version of Windows, you can download this and that's fine. If you have something like a 32-bit version, you got to install Python and download and extract the source code and then execute. If you would like, with PyInstaller, you can create the executable yourself. So now I have already downloaded the metadata injector. Let's have a look at how it works. So as you can see, we are in the 360 video metadata tool for Windows, and the typical icon here is the icon of the PyInstaller. So this has been released with the PyInstaller, and here you have the application. So first of all, we got to open the video. We got to navigate to the folder of interest. So here you can go to videos, and I select this video, and I want to set my video as spherical, and this is a stereoscopic 3D, so I'm going to release also this, and we are going to inject the metadata. So as soon as we press the button inject metadata, we have the indication for the new video. In this case, it is the same name of the input video underscore injected, so we can click save, and the video has the thing injected. So let's have a look at how it looks like. So we open it with the VLC, and as you can see, now we have the 360 video ready to be played and released. Cool. So this, if you're going to upload it, for example, on YouTube, it will result as a 360 video. Nice. Okay, so let's have a look at the output metadata that are present. So FFprobe Ayutthaya, the second video, the one that has been injected, and let's have a look at the metadata present in the format and the streams. So here, at a certain point, we should have a metadatum regarding the spatial metadata. In fact, in this case, we have side data, spherical mapping, and as projection, equirectangular. If you would like to perform also a projection like yaw, pitch, and roll, so yaw goes like this, pitch goes like this, and roll goes like this. So you can do it, and here you have everything as side data. You have a side data type stereo 3D, the type top and bottom, so everything is set correctly. Cool. Still getting back to the previous video, so the input video that we have, the one that is in the equirectangular mode, what we can do is to go from a projection to another, in this case using FFmpeg. So what we would like to do is to get a projection from one to another. So I think that we can do is to go with FFmpeg and getting the input video. And what we would like to do is to use the minus V360 video filter. So minus filter column V, and we call the V360 filter. And as any filter that is paid of respect, we got to set the parameters. In this case, we got to take the input projection and the output projection. So in this case, we have the input that is the equirectangular. We can put either the long name, rectangular, okay, or the short name, that is the E. And then we have to put the output projection. In this case, we put the EAC, the one that from YouTube is by default. And then we put the output file. So in this case, we can also put the settings for the video codec. So CV libx264 minus preset slower. Well, it's okay like this. Minus CRF, put 18, and then we put the output file. So I put ayutthaya eac.mp4. So let's have a look at how it looks like. And after a few moments, we have a new video with the new projection. Good. And here you see how it looks like. If you pay attention, once you download a video from YouTube, you will realize that a video more or less looks like this. And how does the EAC look like? So you see that on the top layer, there is the view as we see it in front of us. Then on the bottom part, there is the interface split in 3 squares, but even here you see the 3 squares. So you see the left, center, and right part. Here you see the bottom, the rear, and the top. So if you set everything correctly and you have this view like this, you can understand how the video on you, so a video coming from YouTube looks like. Cool. Okay, now we have a video that is not an MP4, it is an MKV. If you try to use the spatial media metadata injector provided before, and we're trying to navigate to the folder, this is a proper MKV. If you would like to inspect it, use the command line. We have the MKV as extension, and if we don't trust, we can put an fprobe to get a better idea. Here we have Matroshka, so this is something that is a real Matroshka video. In this case, we cannot use it because this works only on MP4 files. So either you use MP4 alone, or you can use MKV Toolnix. This is okay already in Equirectangular. So what we would like to do is to render it as spherical, so we can perform the 360 view. So I think that we can do. So you can see the video is in Equirectangular. We cannot go around. So what can we do then? We have a tool that is called MKV Toolnix. So here, this is the website, mkvtoolnix.download. And what you can do is downloading for Windows. There's a software in order to use it and add manually the metadata that you have there. So I think that I have already installed. Toolnix. Here I have the GUI right here. And here what you can do is loading the video inside. You can simply drag it and drop it. And here you can have the header editor, so you can open it directly. And here in the video track, you have a voice that is called video projection information. The video projection information, you can take the projection type, and here you can put 0, 1, 2, 3. So in this case, the new value would be to set it to 1. So we add the element here, and we put this to 1. We save. Go header editor and we can validate the values and it says everything is okay. We can save. And here now, if we open it using VLC, you have the video ready to be 360. To understand a bit better about what the 360 with V360 filter does in FFmpeg, I created a script that takes a video of interest. I know that the video is Equirectangular, so sorry for before that I told Equirectangular is written completely, but it is Equirect. So here, what we would like to do is, so we took the Equirect, or also E alone can be okay. And then do the other processing in order to see what is the projection. So let's have a look at how the program works. Let me make the interface a bit bigger. We have the importing of tkinter for this small feature. So what we would like to do is to ask for an open file name. So it will prompt the locations and you can select via the Explorer what is the video you would like to analyze. And in the end, what we have is the input projection, that is Equirect, and it will be used later for the command, the FFmpeg command. And then here we got all the list of output projections. I put in the same line the ones that are supposed to be of the same nature. For example, these are the cube maps, and these are the barrel. This should create the same effect, except these. This should create the same effect on the 3. And we put the thing. Here we have a loop on all the elements in the list, and it will create with the FFmpeg command with a sample CRF of 18 and a preset slower, than up to you if you would like to use something else. Input projection from an input projection that we know from the file into the output projection. So that's it. This is the program we would like to choose. Where did I take all this parameter from? The FFmpeg specs. So here we have all the. We go back to the V360. Here we go. So here we have all the list of all the filters. For the moment, I ignore this, the parameters that are in each and every thing. So here we have a horizontal, vertical, diagonal, field of view. At the moment, they're not of my interest. Just to understand how the thing is going. And that's it.